Looking at is my netlist and my schematic. And, one of the key components in my schematic is a full wave rectifier. It turns AC into DC voltage. And, it's a full wave rectifier, so it converts both waves of the AC. I like that sound when the needle drops.
Okay, so when using an older record player, you have a cartridge, and the cartridge carries your needle. A needle is needed to read the record. That needle there is a phono needle. Phono gives out 0.005 volts. This here is the circuit of a preamp, a equalizer as well. We call that, or a preamp. RIAA being the Recording Industry Association of America. They have these standards to where a record's pressed at a certain pressing to where the bass isn't what it needs to be. Once it goes through here, you get your fully functional sound.
You can use any remote that gives off the right frequency. Most remotes give off the same frequency. So what the circuit was actually the receiver, and you can connect it to any appliance, and then you have the amplifiers and the counter, and then the load. So for the parts, you need a TSOP 1738.
So my project was to analyze and understand the 4 transistors metal detector, and that's my professor. In case you guys don't know who my professor is,
Esteban Ojo.
Esteban.
Ojo.
Oh. Right, there is a picture of the 4 transistor metal detector. As you can see at the bottom is a search. Right, I'm gonna blame the person that gave me this assignment. Almost that we have 4 transistors. You can see Q1, Q1, Q3, and Q4. Actually, the bottom left is supposed to be Q2. If it was my original project, I will label it Q1, 2, and 3, and 4 differently. From left top, Q1, left. The difference is going to be same to Q3, which is the final transistor. Okay. So in here I have an example how it works. So let's say that reference frequency of transistor number 2, Q2, is set. Okay, so my name is Emilio Rivera, and this is my PowerPoint on metal detectors and how they work.
Metal detector. This is a search coil. It's used from 1 or 2 coils, and this is the dirty ground. And let's see, there's a gold coin underground. It basically uses magnetic frequencies.
This is the coil right here. This is money, or whatever gold coins in the ground. It gets read by the coil. It gets into the switch.
What I designed here was the frequency modulated transmitter, or FM transmitter. Here's my schematic. So basically the FM transmitter consists of 4 parts, 5 if you include the antenna. This is the microphone, this is the preamplifier, this is the mixer and oscillator, and this is the power amplifier with antenna at the out. The micro, it finishes off powering up the signal because the signal that goes into transmitter can be pretty low. When I did this, the simulation, I put in the 10 millivolts and it came out to about 1.
Go ahead.
Use radio transmissions safely.
That's the FCC Nazi guy?
My project I call the Mouse House. It's a toy I created to entertain your cat. So, the Mouse House is a cat toy. The structure is a small house with a doorway where a toy mouse will come out and squeak. The house works in 2 ways. The functionality can be standalone by just turning on a switch, or there's a human interaction function that can be controlled through Wi-Fi by an app. Then it's going to move it back and forth, trying to entice the cat to attack and wait for it to, and if the motion sensor detects, then it's going to reset flags which will cause it to start from the beginning of the process again. Transistors, you're always going to be alternating. So if you apply a control voltage to the base, basically it's controlled by your base. I'm actually, in thinking about the process of this,
You are about to experience the awe and mystery that reaches from the inner mind to the outer limits.
I remember watching that show.
1999, he did an article in QRZ magazine, which is put out by the American Radio Relay League. Basically, radio signals are used in a variety of different things. We have radio beacons that are used in aviation. They're non-directional beacons shown on a map like this. When that is transmitting, utilizing the device I'm going to show you, then you can go in a little bit closer and get more fine-tuned with a handheld to try and find a transmitter. Now in amateur radio, they go out and they do T-hunts. You probably heard Professor and I talking about that a little bit. They've got one coming up, T-hunts. And so he built this antenna system for himself so that he can go out and track things more efficiently. They have new technology out today with so with the Doppler effect, as it gets closer, and then you hear the sound change, that's the Doppler effect.